Hello and welcome back to the Scotti-BYTE channel, and this is Scott. Today we want to talk about Docker networking. In my series on virtualization, we have covered virtual machines, otherwise known as VMs, LXD containers, and Docker. VMs virtualize all of the hardware and the operating system, and they're considered to be the most resource intensive and the heaviest of the virtualization options. I've focused on LXD, which virtualizes just the operating system. But Docker containers are virtual containers that just virtualize the application. So all of these choices of containers also offer the option to use virtual networks. Up until now, my primary focus has been on the use of VLANs and networking in general, and I'm usually giving my examples using LXD containers. Today we're going to learn how to extend network functionality in Docker. So in a typical home network, we've got the internet up here, we've got a router, and out of the box, most routers offer a main LAN address range of 192.168.1.0 with a subnet mask of 24. Let's just say we have a Docker host running on that network, addressed at 192.168.1.100, and when you load Docker, it automatically creates a Docker internal network, which is usually hosted down in a private address range of 10.0. something. So in our case, we're saying that my Docker internal network would be something like 10.0.5.0. Now, if we offer application 1 and we just do a typical Docker run or Docker compose, it might have an application that uses internally port 80 and port 443. And if we tell it that we want to offer port 80 on 8080 and port 443 on 4443, then what we'd have is an application that you could connect to from your network by connecting to the Docker host address of 192.168.1.100 at port 8080. Likewise, application 2, which internally might also use ports 80 and 443, cannot reuse the same port numbers, so the number to the left of the colon we change to 8000 and 5443 respectively. Now, if I wanted to connect to this application from my network, I would connect to 192.168.1.100 port 8000, and I would know that I was talking to application 2. However, we've got two other options that we're going to discuss in this video. One of them is that application 3 could actually offer itself on the main LAN at 192.168.1.50, thus being an address on the main LAN, and we would be free to use any port numbers because all of them would be dedicated to a new address. And then likewise, application 4 could run on 192.168.80.10, which might be an address on our managed VLAN, which is the line that I've got above here, assuming that you're using a managed router and the prerequisite is that you have created a VLAN on that router. So default Docker behavior is to run all containers on the one host IP address and expose unique port numbers. That's what we had in example application 1 and example application 2. For example, if we say Docker run and we say port number 8080 exposed externally, and 8080 is what the container uses internally, and we're running an application called Whiteboard, this thing presents itself on the Docker host address. If you want several containers on that one Docker host that you want to run on port 8080, you need to change this number to the left of the colon to something that is unique, otherwise you'll have conflicts. So this becomes more of a problem when you have a lot of containers. Imagine if you had, say, 10 containers that all wanted to use port 80. You'd have to come up with 10 unique port numbers other than 80 to use for the 10 applications. The first thing that we want to be able to do before we can create any of these devices is we have to understand what the state of our Docker is. And so you can always do a Docker PS, and it will show you what processes are running in your Docker. I don't presently have any running right now. This is just a Docker on my local desktop host that I created by installing Docker. Then you can do an IP route show in order to see what your devices are. In my examples, you notice that I have a device called ENP4S0, and ENP4S0 is my Ethernet device in this machine. And so it shows me my routes to my other network. But let's look at our actual devices. Assuming you have NetTools installed, which is sudo apt install net-tools, and you can see I already have it installed. You can use the ifconfig command. And ifconfig will list out your devices. In my case, you always have, if you have Docker installed, you have a Docker device. It's going to set some local Docker network. In our picture, we showed 10.0.5. something. Here, mine happens to be 172.617.0.1. And then my physical Ethernet device is ENP4S0. There's the loopback device. And the only reason I have VIR BR0 is because I happen to be running VirtualBox. Okay, so now that we know our device is ENP4S0, and now that we've looked at our containers, you can also do, besides Docker PS, if you have any stop containers, Docker PS, if you have any stop containers, you can always say Docker PS-A, and it will list all containers, whether they're running or stopped. So in this system, we don't have any containers at all. And then Docker has a command for Docker network ls, list the Docker networks. And normally on a standard Docker system, you're going to have a null network, you're going to have a host network, and a bridge network. And this is what you get by standard. So if we go out and we run a Docker container, and from the example we showed the whiteboard as a typical container, the easiest way to run anything like that is with a Docker run command. So I have Docker run, detach the image. We're going to call the thing test, and we're going to offer it on port 8080, and it's a whiteboard. So I run this thing, it's downloading the container from the Docker hub, it starts it, and I get my prompt back. If I do a Docker PS, there we go, there's the container. Now, since this thing offers on port 8080, I know that if I go to my web browser and I go to my address of my desktop machine, which is my Docker host, which is 172.16.1.225 port 8080, it will go to the whiteboard. So that's that whiteboard application. We can draw things and all that kind of stuff. All right, so if I want to stop that container, I can do Docker stop and that type of thing. So since I'm naming all my containers test, I'm just going to say Docker stop test. A Docker remove test, sorry. Catches on. Docker remove test. And so if I do a Docker PS-A, we're back where we started. First of all, if I reproduce kind of what I did with the whiteboard and just do a Docker run IT Ubuntu Bash, it'll pull down the Ubuntu container, start it, and gives me a prompt. That's what the -IT says. It says make it interactive. And as soon as you start an interactive container, you want to do an apt update. And then I will do an apt install on IP utils ping to give me a ping command. And I can ping 172 192.16.1.58, which is another node of my network, and I can ping it successfully. Okay, if I do an install of NetTools, and I do an if config inside this container, you notice that it gives me a Docker address, 172.17.0.2. So I'm not out on my LAN. This Docker container is inside of the Docker network. It's running the same place where that whiteboard network was running. So now I'm going to exit this, and again I'm going to do a Docker stop test, and I do a Docker RM test. So Docker PS -A, nothing's running again. So we have an option to create a Docker container on your untagged main LAN. And the way we do this is on the Docker host, you actually create a network with the command docker network create mac VLAN --subnet. In my case, my subnet for my main network is 172.16.0.0. I mean, yours might be 192.168.1.0 as we had in that network diagram example. And my gateway is 172.16.0.1. And then I tell it what my parent device is. This is my device that my Ethernet cable is plugged into. And in my case, it's called ENP4S0. And then I decided to give it a network name within Docker, and I'm calling it the exposed network. So now we want to launch a container on that network, and we do that by Docker run. I'm doing a -it, which means run an interactive container, call that container test, and put it on the exposed network, which means the main LAN, and give it an IP address of 172.16.1.200. And the image I'm running is Ubuntu, and I'm opening a Bash shell. So your Docker container would run on a dedicated address of 172.16.1.200. So it really doesn't matter what port names we're going to use or port numbers we're going to use, because we have that entire address all to that container. So make sure the address is outside your DHCP scope, or make sure that it has a DHCP address reservation on your router so your DHCP server does not at any point try to use that address. So each Docker container, therefore, using this procedure, can have its own IP address. Okay, so now what I want to do is I want to create a Docker container on the untagged LAN, on the main LAN. I do a Docker network create mac VLAN. In my case, 172.16.0.0 is the address range with a subnet mask of 16, because that's what my main network is. Yours might be 192.168.1.1, as we discussed earlier, 1.0 rather. And then my gateway is 172.16.0.1. And I say my parent is ENP4S0 because that's what you noticed when I did the if config at my host level. That's what I had before. And I'm calling this network exposed. So it's created that network. And if I do a Docker network ls, there we are. We have a network called exposed. So let's use that exposed network in a Docker run. And this time I'm doing the same thing with the Ubuntu container, but this time I'm saying use the exposed network and grant this particular container the address of 172.16.1.200. So it does that. We're connected to the container interactively. I do an apt update. And I do a apt install with the ping utility, and apt install of net-tools. I ping 172.16.1.58. I can still ping a node on my network. But if I do an if config, instead of my address being a Docker address, it's an address on my main LAN. So this is not the Docker host address. This is the network address 172.16.1.200 on my main LAN for this Docker container. Okay, so now I'm going to do a Docker stop test Docker RM test, and then Docker ps-a, and we're back to where we started. So then you can also create Docker containers on a VLAN. You create a new network device on the Docker host itself. You do a sudo IP link, add link, in my case enp4s0. We're going to go through an example so you can see how you set this up. Name VLAN 80, type VLAN ID 80. So what that does is it creates me a new network device called VLAN 80 for my VLAN 80. And then I give the VLAN 80 device an address with the command sudo IP address add 192.168.80.111 device VLAN 80. And then I'm going to start up the interface for the new device I just created with the command sudo IP link set VLAN 80 up. And then I'm going to create a Docker network to use the new interface I created on the Docker host above. With this command, and this is a single line, and by the way, all these will be in the show notes so you'll be able to look them up. Docker network create Mac VLAN, subnet is 192.168.80.0, and the gateway is 192.168.80.1, and the parent device is VLAN 80 in uppercase, but the Docker network I'm naming is VLAN 80 in lowercase. So that's just what I'm calling it inside of Docker. You could use two different names if you want, whatever you believe provides you more clarity. And then I'm going to start a container on the new network interface. Docker run, name is test, network is VLAN 80, the address is 192.168.80.112. Notice I didn't reuse the address of the interface because that would conflict with it, but I provided my own address. And in both cases, by the way, make sure you have DHCP address reservations for these addresses because we wouldn't want DHCP to reuse those addresses and cause a conflict. And I'm bringing up, again, an Ubuntu with the Bash shell. We are going to have to create a device on our Docker host called VLAN 80 that points to VLAN ID 80. And then I have to give that device an address. So I gave it the 80.111 address. And then once I give that device an address, I have to bring the interface up. And then if I do an if config, you'll notice that magically I have a VLAN 80 and it's running at 192.168.80.111. Now, in order to use that interface that we brought up, we have to create a Docker network with Docker network create Mac VLAN 192.168.80.0 because that's the address range of the VLAN. The gateway is 192.168.80.1, and the parent is VLAN 80 in capitals, and then VLAN 80 in lowercase is the name of the Docker network I want to create. So it's pointing to this as the parent, the thing we just created. And when we do that, it creates that. Now, I can create the same container, Docker run, interactive, name equals test, network equals VLAN 80 in lowercase because it's the name of the Docker network. And then the address of this is going to be 192.168.1.112. We're not using the 111 address of the device because that has to be different, right? Because that's the address on the host. And it's saying use that network, fire up Ubuntu, and there we go. So we do an app update. We do an app install ping. And I happen to notice on that, or know that on that VLAN, I have an address of 192.168.80.55, and I'm able to ping it on that VLAN. And I can do an apt install net-tools. And I can do an if config. And inside this Docker network, I have the address of 192.168.80.112. So I'm actually on that VLAN. So I can do an exit. I can do a Docker stop test, Docker RM test, and then Docker PS-A, and we're back to where we started, except that now we still have the network interface. So if you're no longer using the network interface and you want to delete it, this VLAN 80, we can do that. And the way you delete that network interface is by saying sudo IP link set VLAN 80 in capitals, since that's what we created it as, down. So that sets the link down. And now if we want to delete the device that we created, we do a sudo IP link delete VLAN 80. Now if we do an if config, you'll notice that we have Docker 0, ENP4S0, the loopback, and the VirtualBox interface, but the VLAN 80 interface is gone. Okay, there are some other commands for Docker that are kind of handy to know. One of the commands is rather dangerous, but I'm including it just for information purposes, and that is Docker stop, parenthetically Docker PS-AQ, and what that does is it stops all running Docker containers, and it said it requires at least one argument. We didn't have any Docker containers as we discovered with the previous command, so it couldn't stop any. And then likewise, if you just want to clean a node off and get rid of all the Docker containers you have, you can do a Docker RM with the same command, parenthetically Docker PS-AQ, and it will delete all of them. And needless to say, I didn't have any running. And then you can do a removal of all of your Docker images. So keep in mind, in the process of this demonstration, I downloaded an Ubuntu image, and I downloaded an image for that whiteboard. And if I want to delete all the images from my machine, the downloaded images from Docker Hub, I can use this command, which basically says get rid of all the images. If we want to look at all our images, we can do Docker images ls. Let's see, or maybe it's just Docker images. Yeah, just Docker images, and there they are. And if I want to delete them, I can use that command, and it deletes all of the components there. And if I go back and do the Docker images again, they're gone. So I cleaned off my Docker and set it back to a neutral 0 state. You're probably never going to want to do these things, but they're just an option, commands that you probably ought to know. So in summary, Docker by default offers all containers on the Docker host address, and unique port numbers have to be mapped to avoid conflicts. But Mac VLAN networks can be created inside of Docker that can bridge to any host network device. We can add new network interfaces to the Docker host for the main untagged LAN or for VLANs using these techniques. And using this technique allows applications to run on dedicated IP addresses on your main LAN or on VLANs. Anyway, that's it for today, and thanks for listening. Please subscribe and like to the channel, and we'll see you next time.